tomorrow will be better. A box 10 kilograms is pushed on a horizontal floor by a force of 50 Newton, acting on the box at an angle of 30 degrees with respect to the horizontal as shown for a distance of 5 meters. What is the work done by the applied force? And then find the work done by the frictional force. Dear friends, the coefficient of kinetic friction has clearly been given. Follow me, dear friends. Solution. Now, let me start by telling you that don't make the mistake of using this as your applied force. Alright? First and foremost, what is work done? The formula for work done anywhere is obtained by the force times the distance of action. Now, what is the force we're going to use in this case, dear friends? Be careful not to say 50 Newton, because 50 Newton is not the force which is causing motion along this axis, because this box is moving on this horizontal plane. Therefore, it is another force acting along this horizontal plane which is causing this motion. And because we are only seeing 50 Newton here, this calls to mind the fact that it is a component of the 50 Newton force along this plane which is causing motion on that plane. So the next challenge now is to find the force, the component of 50 Newton which acts along this plane here. Alright, we will use the theorem, the Pythagorean theorem for forces. We will decompose this resultant forces as so. We will have vertically downward, we will have 50 sine 30 degrees, and then along our plane of interest we will have 50 cos 30 degrees. All right, so we've already had this. So let's make the statement and say, but our force here is going to be 50 cos of 30 degrees. Again, this is because this box is moving along this plane and not along the plane of action of the 50 Newton force. So 50 Newton acts like this, but the box moves like this. Therefore, there's a part of the 50 Newton which should surely be acting like this to cause the box to move like this. Alright, so this is it. Therefore, the work done by this applied force is going to be equal to the force which we just obtained here, cos of 30 degrees, times the distance covered. And if you punch this correctly, you should have 216.5 joules, dear friends. 0.5 joules, because the SI unit for work is the joule. Next, this was question 1. Now, question 2 says the work done by the friction force. Again, work done will see the force times distance. But this time around, what is the force in question? Is the friction force. Let's start by finding that friction force. I'll represent it by small fr. Friction force in this context will be given by the normal reaction, that is to say, the reaction which this flow has on this object. Let's represent it on this diagram already by capital N. Alright, the normal reaction force N times the coefficient of dynamic friction, mu k, alright, or mu d if you want. The next challenge now is to find this n, and I want to pause here and make something very clear, dear friends. Don't come here and consider this n to be the weight of this, because there are other forces in action here. Let me draw a free body diagram of what's happening. This is our 50, this is a flow here. This is 50 Newton. Therefore, here we have 50 sine 30, here we have mg, and then up here we have n. Okay, so be careful not to make the mistake in this context and say n will be mg. No, we have to take into account the component of the 50 Newton force which also acts downward. All right, so be very careful with this. So I'm going to clean this up and show you what it gives. So if we take into account, before I clean this up, if we take this into account, we will realize that all the upward forces, the only upward force, by the way, is n, which will equal the only downward force, or rather the downward forces are, we have mg, which is this, plus 50 sine 30 degrees. So clearly the n, which we usually know to be mg, will not be mg today. It will be mg plus 50 sine 30, and this is the reason for which it is so, because a component of this 50 Newton acts downward and has to be considered. All right, so let me clean this up and write this up here. So I would say that N here is going to be equal to mg, which is 10 times 9.8 plus now 50 sine theta. All right, and if you punch this correctly, we should be having 100. Let me punch this very quickly. What does this give us? 9.8 plus this. All right, 123.1 123.1 Newton, not yet joules, dear friends, because this is still just a force. Therefore, the work done by this friction is going to be equal to, no, before the work done, so this is just a normal reaction. Therefore, the friction force itself, all right, therefore, the friction force itself will be this normal reaction times mu d, 0.2. All right, and if you punch this correctly, this should give us plus mu d times 123.1. Okay, 24.61 Newton. So this is actually the friction force. From here we can get the work done by the friction force, which will be equal to the friction force 24.61 times the distance covered. And if you punch this correctly, because 1/5. Okay, so this brings us back here. So it's going to give us 123.1 joule this time around, no more Newton. Okay, now I just want to emphasize that this is a magnitude. This is a magnitude of the work done by the friction force. This is a magnitude here because naturally from here we should have a negative sign. Why negative? Because this force is acting against motion. So it should actually be some negative here. All right, so that this stands out to be the magnitude of the work done by the friction force, because tomorrow will be better.